Okay, hi student. We now continue on a new subtopic 11.5, infinite geometric series. Some sequence go on indefinitely. This means that this means they do not have a fixed number of terms. What is the meaning of indefinitely? That means it go on and on, which also means that you do not know where is the end. So describe what happens when you sum the terms of each of these infinite sequences. So the first one we have this. The first one is an AP. The terms get bigger and bigger. 1 plus 4 you get 5, 5 plus 4 you get 9, 9 plus 4, 13 plus 4, 17, and so on. Now the next sequence, 2, 4, 8, 16, and 32. So the rules here is times 2. And this is a GP, geometric progression. Terms get bigger and bigger. Sum of terms get bigger as more terms are added. And the last sequence over here, you have 1, 1 over 2, 1 over 4, 1 over 8, 1 over 16, ... So for this sequence, you have to times 1 over 2. Other than times 1 over 2, it can also be divide by 2. You can also divide by 2. Each of the term you divide by 2 to get the following answer. Yeah, because divide by 2 is the same as times 1 over 2. 1 over 2 is the reciprocal of 2. So here, this is a GP, terms get smaller and smaller. Sum of terms does not change very much, and as more and more terms are added. So here we are talking about converging to a sum. The sum of infinity of a series cannot be found for an arithmetic series, a geometric series which has a common ratio such as 2. Now, but the sum to infinity of a series can be found for geometric series which has a common ratio such as 1 over 2. It's getting smaller and smaller. So here we go. We have this formula for sum of infinity of a GP. The sum to n terms of a GP is Sn equals to A times 1 minus R to the power of n divided by 1 minus R. This can be written as Sn equals to A minus A R to the power of n over 1 minus R. This is equals to, this also can be written as A over 1 minus R minus A R to the power of n over 1 minus R. So what we do is that we split our numerator. So instead of grouping everything together and write it as a single fraction, we split it to 2 fractions. Now consider some values of R to the power n when R lies in between -1 and 1 and n approaches infinity. So now let's have a look what is going to happen. When my R is -1 over 4, R to the power of n as n approaches infinity. That means your n increasing to a very big number. What will happen to my Rn? It will go to 0. 0, 0, 0, 0, 0. So with that being said, we can actually eliminate the second fraction. You can take away the second fraction, as we know that as when I put a bigger a very big value of n, this second fraction is approaching 0. It is not equal to 0, but it is going near to 0. It will become a very, very, very small number. So the sum to infinity of a GP as infinity is equals to a over 1 minus r. Now let's check a work example 18. The first three terms of a GP are 25, 15, and 9. Write down the common ratio. To find your common ratio, R, use the second term divided by your first term, so you get an answer of 3 over 5. You can also use third term divided by second term, which is 9 over 15, can be further simplified as 3 over 5. Now B, find the sum to infinity. Your first term A is equals to 25. Your R is equals to 3 over 5. So your S infinity equals to 25 over 1 minus 3 over 5. So you have 25 divided by 2 over 5. So you get S infinity equals to 62.5. It's a very straightforward example for this. Now let's move on to the next work example. A geometric progression has a common ratio of negative 4 over 5, and the sum of the first 4 terms is 164. Find the first term of the progression, and B, find the sum to infinity. Now let's check on our questions and see what kind of information that we have. We have common ratio, your R equals to negative 4 over 5. The sum of the first 4 term, which is your S4, is equals to 164. So now I need to look for my first term of the progression. What is my first term? My first term is the first term of a progression is commonly known as A. So now let's substitute my Sn. Since here my R is negative 4 over 5, which lies in between negative 1 and 1, it is advisable for me to pick this formula, which is Sn equals to A bracket 1 minus R power n close bracket over 1 minus R. So that's why I'm using this formula for this question. What is given here? Sn. Sn, your S4 is equals to 164. Yeah, 164. Your A is being given. No. Your A is something that you're looking for. R is something that you have been given, which is negative 0.8. So now once you've done with this step, replace your S4 with 164. So here they kind of skip the steps here already. So you have 1 minus negative 0.8, which is 1 plus 0.8, you get 1.8. Here you have 1 plus 0.8 to the power of 4. So when you add wait, before that, let's check on this thing carefully. Yeah, I know that sometimes for some, when we see the negative and negative, we tends to get very excited. But here, I have a negative 0.8 raised to the power of 4. So it is important for me to solve for this part first. You have to solve for this part first according to our board mass. So now let's get my calculator to help me on this. When I have negative 0.8 to the power of 4, I get 0.40 0.4096. Okay, back to this questions again. So this part of this thing, if you're looking to calculate, you get 0.4096. So now, then only you use 1 minus 0.4096, which you get 0.5904. Then you multiply by the A outside the bracket. So you reach up to these steps. Now on this side, you have to look for my A. So my A is, well, I skip some steps here. So your A, before you reach this step, your A is equals to 164 times 1.8 divided by 0.5904. Then only you get an answer of 500, which is this. Yeah. Okay, now once we have found the first term of the progression, 500, let's continue to find the sum of infinity. The sum of infinity, we have a formula of S infinity equals to A over 1 minus R. So your A is what we have just found here, 500, divided by 1 minus R, 1 minus negative 0.8. So we get an answer of 277 and 7 over 9 as your answer.